Welcome back to our biomass class, where we're delving deeper into the fascinating world of conversion of biomass resources into heat and power. This video was made with the support of Energy. Remember that this biomass energy course has 9 lessons. Lesson 3 has 3 main topics. This video focuses on energy crops. What are the main energy crops? What are their main characteristics? How should they be managed? Energy crops are low-cost and low-maintenance crops grown solely for energy production, not for food. The plants are generally categorized as herbaceous or woody. Herbaceous energy crops are mostly types of perennial grasses. This group includes plants like miscanthus, switchgrass, bluestem, elephant grass, and wheatgrass. Short rotation woody crops include many types of fast-growing trees such as willow and poplar. Bioenergy crops are an important source of renewable energy and are a possible mechanism to mitigate global warming. Second-generation energy crops like miscanthus and short-rotation forestry are becoming more and more important and increasingly visible. The analysis of sustainability for growing energy crops should focus on greenhouse gases emissions, water and air security, biodiversity, erosion control and soil security, and soil carbon changes. That can be compared with the most common agricultural crops as reference. The objective is to produce bioenergy without trade-offs for land use change or food security. Let's focus first in herbaceous crops. How crops are managed and processed influences productivity, costs, and biomass quality. When growing herbaceous energy crops, it must be taken into account that after planting, a minimum of 2 to 3 years is required to achieve maximum annual yields. Permanent irrigation may not be cost-effective. To obtain a high yield, key determinants are sunshine, temperature, and water availability. Their annual variability results in annual yield variations. Let's see an example of herbaceous crop, the Miscanthus giganteus. Miscanthus giganteus is a sterile and non-invasive hybrid plant. It grows to heights of more than 4 meters in one growing season, from the 3rd season onwards. Miscanthus is quite an adaptable energy crop. It grows on a range of soils, from sand to high organic matter soil. A typical production can be around 25 tons of dry plant per hectare. However, the yields are strongly influenced by annual rainfall frequency and soil water retention at any site. Miscanthus can be burnt directly in biomass boilers or processed further into pellets or briquettes. Let's see how to manage herbaceous crops. Harvesting is made usually once during the growing season and can take place during the winter or early spring. Delayed harvests may cause some loss of biomass. Harvesting is generally done with conventional cutting, raking, and baling equipment. Baling can be made in different shapes like rectangular, round, and compact rolls, each suitable for different scales of energy production facilities. Let's move to woody crops. Woody energy crops are fast-growing trees that are harvested within 5 to 8 years of plantation. These crops include hybrid poplar, hybrid willow, silver maple, eastern cottonwood, green ash, black walnut, sweet gum, sycamore, and so on. Let's see an example of a short rotation crop, the hybrid poplar. Poplars are more desirable for biofuels than many other woody crops because of their fast growth, their ability to produce a significant amount of biomass in a short period of time, and their high cellulose and low lignin contents. Poplar is harvested every 3 years using a single pass system that cuts and chips the trees as the harvester moves down the crop row. Its productivity depends on the type on clone and on the type of management. Therefore, let's move to the management of short rotation crops. Let's start with the production phase. Coppicing is a traditional method of woodland management, which exploits the capacity of many species of trees to put out new shoots from their stump or roots if cut down. Coppicing works well for bioenergy systems, where the goal is to maximize the biomass. For example, poplars are cut near the ground at harvest in winter when the soil is frozen. In the spring, new stems sprout from the rootstock to regenerate the stand. The trees will be harvested again on a continuous cycle that can be repeated every 3 years. The poplar rotation lasts for 18 to 21 years. Thus, trees are replanted after 6 or 7 cycles. The key determinants that influence short rotation crops' yield are water availability, light, temperature, and weed control, and also the density and rotation time. Density refers to the number of plants per hectare. The density influences the time that trees are allowed to grow. Short rotation lasts typically for 2 years. The most common cultivation system involves a very high planting density of about 5,600 plants per hectare and biennial shifts. Short rotation coppices can supply large quantities of biomass per hectare per year. As reference, a plantation can yield from 8 to 18 tons of dry wood chip per hectare per year. A power station requires around 100 hectares of SRC for 1 megawatt of power capacity. An alternative is the medium rotation coppice, which represents a compromise between the previous one and traditional poplar cultivation. In this case, the cutting shift is 5 years and the drums have a diameter sufficient to be used as biomass or for cellulose rod. In that case, they can have from 1,100 to 1,600 plants per hectare, much lower density than for short rotation. Okay, but how short rotation crops are harvested? There are 4 different types of harvesting SRC. Direct chip harvesting, harvesting as entire rods, harvesting into round bales, and harvesting into billets. To store the SRC more easily, shoots are harvested as whole stems. Then, they can be dried until the next autumn when the moisture content of the wood will decrease to about 30% on average. Then, the dried stems can be either converted into wood chip or cut further into billets, depending on use. For the production of wood chips, the most efficient technique is to use direct chip harvesters that cut and chip the shoots on a loading platform. Direct chipping in the field is less costly than separate chipping in the store. However, the wood chip should be well stored to prevent degradation. Cutting, chipping systems are more commonly used in North America, while cutting, bundling equipment is widely used in Europe. What are the production costs and the benefits? The large initial investment cost of plantations may be intimidating since there is no financial payback for 4 years from the initial establishment. Although SRC is a relatively low-return crop, it requires low maintenance. And planting SRC is a way of utilizing difficult and idle fields, with little need for pesticides or treatments. Let's see a comparison between short and medium rotation coppice. Short rotation coppice has inexpensive harvesting systems and quickly goes into production. However, supplies lower quality biomass with low market value, around €12 per ton of green biomass. The medium rotation coppices are more flexible in managing the rotation. They entail longer waiting times for the plantation investment to go into production. However, they allow obtaining higher quality biomass with a higher price, around €20 per ton of green biomass. Wrapping up, biomass can be produced from energy crops. Productivity, costs, and biomass quality depend on how crops are managed and processed. Herbaceous energy crops are mostly types of perennial grasses such as miscanthus. For each species, yields are strongly influenced by annual rainfall frequency and soil water retention. Harvesting of herbaceous energy crops is usually been accomplished using conventional mowing, raking, and baling equipment. Miscanthus can be burnt directly in biomass boilers, or processed further into pellets or briquettes. Short rotation woody crops include many types of trees such as hybrid poplar. Short rotation coppice is used to manage poplar plantations. Short rotation coppices can supply large quantities of biomass per hectare per year. However, its productivity depends on the type of tree, its management and weather conditions. Cutting, baling or cutting, chipping systems are more commonly used in North America, while cutting, bundling equipment is widely used in Europe. Direct chipping in the field is less costly than separate chipping in the store.